Here's a really elegant, beautiful statement in number theory. D of n is the number of divisors of n. So it's interesting to count how many divisors are there for n. So for example, if I have 12, d of 12 is the number of divisors of 12. Now 12 has divisors of 1, 2, 3, 4, 6, and 12. These are the divisors of 12. And notice that there are 6 of them, so d of 12 is equal to 6. On the other hand, if you have a prime number p, for example, p is any prime number, then d of p is just going to equal to 2, because the only divisors of a prime number are 1 and itself. So here's a beautiful question. How many divisors are there of n? Can we estimate it from above and below? In this video, we're going to do it from above. We're going to say that for all n, the number of divisors of n is less than or equal to 2 times the root of n. So in general, the number of divisors of n can be bounded above like that. We're going to prove that, and it's a really beautiful argument. Now, one comment I'll make is, of course, the number of divisors of n is always less than or equal to n. Right? It's always less than or equal to n because there are n numbers from 1 through n. Not all of them are going to be divisors in general, of course, but the total number is less than or equal to n. But here we're proving something a bit stronger than that, so let's get into it. Beautiful number theory argument. Let's prove the statement. So if we think about divisors of n, then any divisor of n comes with a complementary divisor. Divisors come in pairs. If a is a divisor of n, there's also going to be another divisor b, so that a times b is equal to n. Now here's the interesting statement. If you have this product, at least one of a or b has to be less than or equal to the square root of n. Why is that? Well, if for a contradiction, so here's my claim, I'm going to write it down first of all. Claim is that either a is less than or equal to the square root of n, or b is less than or equal to the square root of n. Now, why is this true? Well, if both a and b were greater than the square root of n, then we would say that if a greater than the square root of n, so here's the proof of the claim, it's a proof by contradiction. If a and b are both greater than the square root of n, and this is a strict inequality, then we would know that the product a times b is going to be greater than the square root of n times the square root of n, which is going to equal to n. And that of course doesn't make sense because ab is equal to n. So in fact, one of them has to be less than or equal to root n always. And now we're almost at the end of the proof. Because here's a cool statement. If we think about the divisors of n, they're going to either be between 1 and root n, or between root n and n. Okay, so if you count all the divisors, and I'm going to write it here, if you count all the divisors, you have the divisors that are, so the divisors a, such that 1 less than or equal to a less than or equal to root n, and of course they're going to be at most root n of them. Right? I mean, they're root n numbers, so this is a very weak estimate. There are many numbers that are not going to be divisors, but at the most you're going to have root n divisors here. So I'm going to write it down as such. You're going to have root n divisors, so root n divisors between 1 and root n. And secondly, if you look at divisors between root n and n, okay, every divisor is between 1 and root n or root n and n. So if you look at divisors root n less than a less than or equal to n, okay, divisors like this, then we observe that for each such divisor, there's going to be a complementary divisor, and that one is going to be less than or equal to root n. By our argument here, at least one of the factors in the product has to be less than or equal to root n. So if the first divisor we take is greater than root n, the complementary divisor n over a has to be between 1 and root n. Okay, so in that way, we see that because 1 is going to be less than or equal to n over a is going to be less than or equal to root n. We therefore know that there are going to be root n divisors between, at most root n divisors between root n and n. Okay, so here also we're going to have at most root n divisors. Okay, this is an inequality. Actually, this is the key point because of course this inequality is pretty obvious. I mean, then there are root n numbers from 1 to root n. But between root n and n, there are a lot more than root n numbers in general. Okay, if you think about like 110, okay, 10 is the root of 100. There are 10 numbers from 1 to 10, but 90 numbers from 10 to 100. But the point is that out of those, the divisors, the number of divisors has to be less than or equal to root n by this trick. So that's very important. So in total, they're going to be less than or equal to 2 times root n divisors. And that's the proof. Very cool, very elementary. Love these number theory proofs. You can do a lot better than this. And I'm going to do a video on it. Drop a comment down below if you want to see that. You can actually prove that there is a constant c, so that for each epsilon greater than 0, and this is going to be really, really cool, for each epsilon greater than 0, the number of divisors of n is less than or equal to c of epsilon times n power epsilon. There is some constant c depending on epsilon. So in the case of epsilon equals half, you have n power half is the square root of n, and then the constant you can take to be 2. That's what we proved in this video. But even if you take n power the 100th root of n, or the millionth root of n, you can still show the number of divisors is less than or equal to some constant times that for all n. Okay, the constant does not depend on n. That's really beautiful. If you want to see more content on my channel, like the proof of this, drop a comment down below, and check out my next video. It's a beautiful number theory video about why two numbers, how do you find the probability that two numbers are relatively prime? They don't have any common divisor. It's a really cool video, and don't forget to like and subscribe and support my channel on Patreon. If you're really enjoying my content, you make a huge difference. The exclusive perks there and small contributions go a long way to helping me produce infinite free accessible math content. See you in that video or another fun video over there.